Okay, hello everyone. Okay, so another data analysis video, and again I'm focusing on tidying and wrangling data. So this video I've called it More Data Wrangling 9. This builds on the previous video, More Data Wrangling 8, in which I showed how to aggregate data using multiple functions. So what I'm going to do in this particular video is kind of do a little bit more of that using a different variable. And then show you how you can obtain pivot tables and cross tabulations in using different methods. Okay, so to get started, I'm going to import pandas and numpy. Mostly we're using pandas here. So I've imported pandas as PD, numpy as NP as is standard. And again, I'm using the same data frame that I used in More Data Wrangling 8 video. So I'm importing this multi-level data file.csv that's saved on my laptop. So this spreadsheet's got data from a study which looked at an economic game where a within subjects design was used, a repeated measures design was used. So participants played an economic game, and there were a couple of conditions. They contributed data points prior to a resource being depleted and after a resource had been depleted, so pre and post depletion essentially. So I'm going to import it using the pandas pd.read_csv method, and I'm going to save it as pre-post as a data frame or pandas data frame object. And I'm going to run this data types method so we can just inspect these, because there's something of interest that I want to change. And a lot of the data frames, as you can see, you get data in all sorts of conditions, and you've got to try sort it out and get it tidy so you can analyze it in some way. An interesting thing about this data frame is it's imported the data as different. It's kind of pandas has it's identified in many cases whether an object is floating point, decimal, an integer, or whether it is a string or an object. And so most of the time it gets it right, but it doesn't always. So here the variable mean consumption, which is one of the dependent variables, the outcome variables in this particular study, has been imported as an object, so as a string. And it's not, it should be a decimal, it should be a floating point number. So if I run the above cell again, and we ask for pre-post.head, you should be able to see there mean consumption should be a decimal, and it's currently a string, which is kind of a bit weird. It's saved as text essentially. So one of the first things I need to do is, I've demonstrated this sort of thing on previous videos, but in order to do anything with this, the kind of manipulations I'm going to do in this video, I'm going to focus on this mean consumption variable, which was one of the key independent variables in the research. So participants played this game, and we looked to see how much they consume and if that differed before they depleted a resource or after they depleted a resource. Okay, but it's not currently, we can't really do any maths with it or analyze it because it's currently saved as a string object. So I'm going to have to convert it to a floating point number, to a decimal. So to do that, I'm going to basically take the name of it, take that particular variable from the pre-post data frame, and I'm going to use the .apply method on it, and I've kind of demonstrated this in previous videos, and I've specified use the pandas to numeric method, and I've asked it to coerce any errors. So that basically means it will convert any missing values to NaNs, not a number. Okay, I don't believe there are any missing values from this particular variable, but I've added that argument anyway. And so if I didn't have that and there were missing, if there were errors, if there were missing values, it would probably spit out an error message at us. So let me run that, and if we now have a look, the above should have worked. Yeah, we can see now that the data type for mean consumption is floating point number, which is correct, which is what we want. is a kind of a mean score. So mean consumption, if we take that variable as a whole, so the mean consumption for the whole data set, and we work out the mean for it using this the dot mean method. So all I've done here is I've specified pre-post data frame dot mean consumption, the name of the variable, dot mean. So calculate the mean. And what you see is the mean consumption for pre and post for the whole data frame is about 23.2 units if we round that up. Okay, so that's interesting. So we know the mean for all entries for all values in the data frame. But we might be interested in looking at this in a more granular way. So we might want to calculate the consumption means for different levels of, say, the condition variable. So the condition variable in this data set was a categorical variable. It's shown as an integer here, which isn't correct, but won't affect what we're about to do. So the condition variable had two levels, 0 and 1, if we look at the data frame. 0 is the only ones you can see, but 0 and 1. And what that recorded was whether the participants could see each other, they were sat face to face when they were playing this game, where they were consuming resources, or whether they were anonymous. They never saw each other in separate rooms. Okay, so we might want to work out the mean by group, essentially. And the way to do that is we're going to use the group by method. So we're going to specify the data frame pre-post, specify the group by and telling it what to group by in parentheses. So we're going to group by condition, the condition variable, and then we want to take the mean of mean consumption. So if I run that, we see we've got condition 0 as a mean of 20.54 and condition 1 has a mean of about 28.28. So from what I can remember, condition 0 was seen, so the players were sat in front of each other when they were making their decisions, and condition 1 was anonymous, kind of unseen. They never saw each other, they never met face to face. So you can see here in terms of consumption, we've got kind of a difference in means between these two groups. Already interested in that, you maybe would want to do some sort of statistical analysis to see if there is a difference between those two groups. But we can get even more granular than this and basically pass a list of more than one category for pandas to group by. So what I've done here, very similar to above, I've used pre-post data frame, specified the group by method, and again we're using we're looking at the mean of the mean consumption scores, but this time rather than just passing condition, I've passed it a list of two categorical variables, condition and pre-post, and I've put those in square brackets to specify that they are a list. So if I run that, what you can see now is we've now got means by condition, split by condition, and whether it was pre or post depletion. So you can see 0 would be the scene condition pre-depletion, 0, 1 would be the scene condition post-depletion, 1, 0 would be the unseen anonymous condition pre-depletion, 1, 1 would be unseen post-depletion. And you can clearly see there that we've got differences in the means pre and post depletion. So in the scene condition, pre-depletion, the mean consumption was like 30.26. Post-depletion, it was 9.88. So participants consumed less once they depleted that resource. So once their consumption had started to damage the resource and reduce how much was available. And you can see here for the unseen, the anonymous condition, is pre-depletion, the mean was still much higher than for the seen compared to the unseen condition, but theirs also reduced post-depletion. Okay, so that's kind of nice, but we can reshape this output. So it's to get it into to create a nice kind of HTML data frame, pandas data frame, using this kind of unstack method. So if I run this, what I've done here is I've specified the exact same argument as above so we can group by condition and depletion, pre-price depletion, and get the means for each of those groups. But the thing I've added on to the end here is this unstack method. So that's the only difference. And if I run that, what you can see is it's given us this nice rows and columns, pandas, HTML style data frame object, which has exactly the same values here as we've got in this table here, but it clearly looks nicer and it's sort of easier to interrogate. So we can see that, you know, when condition was 0 and pre-post was 0, it means 30.26. So seen pre 30.26. Okay. All right, so that's quite useful. We can also, in a very similar way, it can be convenient for us to create data frames like this one using the pivot method instead. So what I've done here is I've specified the data frame pre-post and the method pivot table. Okay, and then I've passed a series of arguments, and this is going to give us the same table as we've got here, but I've specified a number of arguments. So I've asked for the index to be condition. So the index here means the rows. So the rows are going to be the condition variable. The columns are going to be the pre-post depletion variable, just as they are on this particular table. The values we're going to extract from the mean consumption variable, and I'm saying the aggregate function I want to use is the mean. So essentially this whole thing here is another way to say exactly what we did in the previous cell there. And if I run that, you can see we get the same output, the same looking table, the same output, but it's just kind of another way. And a pivot table can be quite a convenient thing to use because there are extra things, there are extra arguments we can add when we use this pivot table method from pandas. So we can add margins, so we can add the marginal means, things like that. And we do that by specifying margins equals true. So we add this extra argument here, margins equals true. So if you look at what I've got here, it's exactly the same as the cell above, but we've got this additional argument of margins equals true. Sorry. So we're pre-post pivot table. The rows are going to be condition variable. The columns are going to be pre-post depletion. The values that we're going to look at come from the mean consumption. We're going to use the mean as the aggregating function that we're interested in, and we're going to ask for the margin, column and row totals effectively. And that gives us a table like this. So we can see we've still got these same means as we've got in the top, but now we've got these marginal means as well. And if you recall, so what this is if we just consider the condition to be seen and we ignore pre-post, don't split by pre-post depletion, then we see we've got a mean of 20.54. If it's unseen, we've got a mean consumption of 28.28, and that should look familiar because we got those when we just worked out the means by one variable. Look here, when we just looked at the difference in means by condition, those were the same values as there. So hopefully it's clear what those mean and where they come from. Okay, so that's quite useful. It's handy to know, but often when you have a table like this, we usually use it for count data. So we can use this exact same method, pivot table method, and obtain a cross tabulation of count data, so frequency scores. And the way we do that is by changing the ag function argument, the aggregate function argument, from mean to count. So if you look above, exactly the same setup as before, but here we specified we wanted to use the mean, and this one we're going to use the count. So if I run that, you can see now those have been converted to counts, and the row and column totals as well will kind of will be the sum of these counts. So you can see 114 plus 104 will give you 280. Okay, so that's kind of just one way that you can get more granular information out of a variable when you know, by working out the mean for the whole variable, working out the mean via condition, and then how you can present them and set them out nicely in pivot tables.